Hello class, I hope everyone has already mastered SAS 1 because this time I will introduce another lesson which are elimination of arbitrary constants and families of curves. At the end of the lesson, students should be able to define the arbitrary constants, eliminate arbitrary constants, obtain the differential equations of families of curves. Letter C is the application of the elimination of arbitrary constants. So let's define first what is arbitrary constants. Arbitrary constant is a constant whose value could be assumed to be anything, just so long it doesn't depend on the other variables in an equation or expression. For example, y equals c sub 1 e to the negative 2x plus c sub 2 e to the 3x. The x variable there is the independent variable, while y is the dependent variable. So c sub 1 and c sub 2 are the arbitrary constants. So arbitrary constants can be any values, okay? For example, if our equation is x plus y equals 5. So what are the values for x and y that will result to 5? X can be 4, then y is 1. Or x can be 1, then y is 4. X can be also 6, and y can be negative 1. Or x can be 7, and y can be negative 2. All of this will result to 5, right? So, arbitrary constants are any values as long as it makes the equation true. Okay? There is another constant, and that is parameter constant. A parameter is a variable that is held constant when the function is used. Varying a parameter gives you a family of functions. So, parameter has one fixed value, not many values. For example, dy over dx equals sine beta x. Beta here is the parameter. Another example is dy minus 2 dx equals 2e to the omega x. And the omega is the parameter. So what are the terms to look out? If the problem has written there fixed constant or parameter, or another word is held constant. Okay? You will know that it is parameter because you will see in the problem fixed constant, held constant, or parameter. Note that a parameter must not be eliminated. It is not counted as arbitrary constant. Okay? Next, elimination of arbitrary constants. This is the process of eliminating the arbitrary constants present in a given equation to obtain the required differential equation. For example, our equation is y equals c sub 1 e to the negative 2x plus c sub 2 e to the 3x. There are two arbitrary constants. Then, when the equation undergone the elimination process, all the arbitrary constants will be gone. And the result is already differential equation. So what are the properties of elimination of arbitrary constants? One is the order of dE is equal to the number of arbitrary constants in the given relation. It means the number of arbitrary constants will tell you how many times you will derive the equation. For example, if the order is 2, then you will derive the equation twice. If the order is 3, then derive the equation thrice. That is for number 1. For number 2, the DE is consistent with the relation. It means when the equation underwent the elimination process, there is always a solution. Okay? For number 2, there is always a solution. Number 3, the DE is free from the arbitrary constants. So no more arbitrary constants when when the equation underwent the elimination process, and the result is already differential equation. Next. So what are the methods of elimination of arbitrary constants? We have 3 methods. Elimination of arbitrary constant by isolation, by determinants, and by substitution. So, let's break down for each method. Elimination of arbitrary constants by isolation, it is used when one arbitrary constant is present. Only one arbitrary constant. So what are the steps? First, you have to take the derivative of the given equation. Next, isolate the constant or the arbitrary constant on one side of the equation. Third, input the arbitrary constant to the original equation. So let's apply this one. Example, eliminate the arbitrary constant of y equals x plus c sub 1 e to the 3x. Our arbitrary constant here is c sub 1. Since there is only one arbitrary constant, then we will use the method by isolation. So what is the first step? You derive the equation once. So what is the derivative of y? The derivative of y is y prime. And the derivative of x is 1. The derivative of c sub 1 e to the 3x is 3 c sub 1 e to the 3x. Okay? Second step is to isolate the constant on one side of the equation. Our arbitrary constant is c sub 1. So, since this is already positive, we will transpose 1 to the left side. So, 1 becomes negative. So, y prime minus 1 equals 3 c sub 1 e to the 3x. Since we want to isolate c1, we have to divide both sides by 3 e to the 3x. We want to cancel 3 and e to the 3x on the right side. So, 3 and e to the 3x are cancelled out. So, what we have now is c sub 1 on the right side, and on the left side, we have y prime minus 1 over 3 e to the 3x. And the third step is to input the arbitrary constant to the original equation. So what is our original equation? Original equation is y equals x plus c sub 1 e to the 3x. Then we will input the value of c sub 1. So y equals x plus c sub 1 is equal to y prime minus 1 over 3 e to the 3x, then multiplied to e to the 3x. Our c sub 1 is y prime minus 1 over 3 e to the 3x, then multiplied to e to the 3x. So we can cancel e to the 3x. Then we get y equals x plus y prime minus 1 over 3. Then the practice in differential equations, there should be no denominator. So to get rid of the denominator, we will multiply the equation by the denominator, and that is 3. Then distribute 3 times y is 3y equals 3 times x is 3x. Then 3 times y prime minus 1 all over 3. 3 is cancelled out, so only y prime minus 1. Then you arrange your answer. So, since the derivative is on the right side, so all terms must be on the right side. So, y prime plus 3x. So, if we transpose 3y to the right side, it becomes negative 3y. Then, copy negative 1 equal to 0. So, this is our solution. No more arbitrary constant. And the equation is already differential equation. Another way of writing the solution is you change y prime into dy over dx. So we can write the equation into dy over dx plus 3x minus 3y minus 1 equal to 0. So this is another way of writing our solution. Another way of writing our solution is we put the equation into differential. So to do that, we will multiply the equation by dx to get rid of the denominator. So this is our equation, dy over dx plus 3x minus 3y minus 1 equal to 0. Then we multiply both sides by dx. So dx is cancelled here. So we have dy only. And dx will be distributed to these terms, 3x, negative 3y, and negative 1. So we will put the dx outside for 3x minus 3y minus 1 equal to 0. So this is another way of writing down our solution. Another example. Eliminate the arbitrary constant of c times y sub y to the power of 2 equals x squared plus y. There is one arbitrary constant, so we will use the elimination by isolation. So first step is to derive the equation. So what is the derivative of cy squared? The derivative is 2cy y prime, right? And the derivative of x squared is 2x. And the derivative of y is y prime. Then, we isolate the arbitrary constant. So, we divide both sides by 2y y prime and the other side 2y y prime. So, 2 is cancelled out and y prime. So, only c is left on the left side. So, c is equal to 2x plus y prime over 2y y prime. Then, the third step is to input the arbitrary constant to the original equation. Our original equation is cy squared equals x squared plus y. Then, our c is 2x plus y prime over 2y y prime, right? Then multiplied to y squared equals x squared plus y. Then y squared over y, cancel 1y, and y in the denominator is cancelled out. So, we will get 2x plus y prime times y over 2y prime equals x squared plus y. Then, to get rid of the denominator, we will multiply the equation by the denominator. So, we will multiply the equation by 2y prime. So, distribute. This will be cancelled out. So, only 2x plus y prime times y. Then here, multiply. So, x squared plus y times 2y prime. Distribute. So, distribute So this becomes 2xy plus yy prime equals x squared times 2y prime. So we will get 2x squared y prime. Then plus 2y y prime. Then add like terms. So we have y prime here and on the right side. So combine like terms. So 2x squared y prime plus 2y y prime, then transpose y prime to the right side, it becomes negative. And transpose 2xy to the right side, it becomes negative 2xy equal to 0. Then get the common. The common for these three terms is y prime, right? So put the common outside the three terms. So 2y minus y, then times y prime minus 2xy equal to 0. Then 2y minus y is y only. So we will get 2x squared plus y prime minus 2xy equal to 0. So this is our solution. Another way of writing our solution is by changing y prime into dy over dx. So we have two x squared plus y. So y prime now is dy over dx minus 2xy equal to 0. So this is another way of writing our solution. Next is to put our equations into differential. So we will multiply both sides by the denominator dx. So multiply by dx, dx here will be cancelled out. So only 2x squared plus y dy. Then multiply dx to this term, we get 2xy dx equal to 0. So this is another way of writing our solution. Elimination of arbitrary constant by determinants. It is used when two or more arbitrary constants are present. First, take the derivative of the equation depending on the number of arbitrary constants. So if there are 2, you will derive the equation twice. But if there are 3 arbitrary constants, you derive the equation thrice, right? Then after that, you will use the determinant to get the dE. Example. Eliminate the arbitrary constant of y equals c sub 1 e to the 2x plus c sub 2 e to the 3x. C sub 1 and C sub 2 are the arbitrary constants. So we have 2 arbitrary constants, meaning we will derive the equation twice. So first step is to derive the equation twice. Then use the diagonal method or use the determinants. So what is the first derivative of our equation? Derivative of y is y prime. What is the derivative of c sub 1 e to the 2x? The derivative is 2c sub 1 e to the 2x. And the derivative of c sub 2 e to the 3x is 3c sub 2 e to the 3x. We will derive again because there are 2 arbitrary constants. So the derivative of y prime is y double prime. And the derivative of 2c sub 1 e to the 2x is 4c sub 1 e to the 2x. The derivative of 3c sub 2 e to the 3x is 9c sub 2 e to the 3x. Do we need to derive again? No more. Because there are only 2 arbitrary constants. So we have to derive the equation twice only. Next is to use the determinants. Here, to determine the determinants, we will use the diagonal method. So First, you write down in the first column, write the y and its derivative. So, I will arrange the equation first. How many arbitrary constant? 2. Original equation is y equals c sub 1 e to the 2x plus c sub 2 e to the 3x. In the first column, we write all the y and its derivative. So, y prime, then y double prime. In the second column, we write the coefficients of the common factor. The common factor is c sub 1 e to the 2x. So, what is the coefficient for first equation? The coefficient is 1, right? For the second equation, the coefficient is 2. And for the third equation, the coefficient is 4. What is another common factor? The common factor is c sub 2 e to the 3x. Then you write down the coefficient. For the first equation, the coefficient for c sub 2 is 1. Second equation, the coefficient for c sub 2 e to the 3x is 3. And for the third equation, the coefficient for c sub 2 e to the 3x is 9. Then, you copy the first two columns and put it next to the third column. So, our first and second column is y 1, y prime 2, y double prime, then 4. Then, multiply diagonally from top to bottom minus multiply diagonally from bottom to top. So, diagonally, meaning from top to bottom, so multiply y times 2 times 9. So, y times 2 times 9, that is 18y, right? Then, 1 times 3 times y double prime. That is positive 3y double prime. Then, multiply again. 1 times y prime times 4. And that is 4y prime. So, from top to bottom, minus bottom to top. So, bottom to top, so multiply y double prime times 2 times 1. Diagonally, okay? So, y double prime times 2 times 1 is 2y double prime. Another one, 4 times 3 times y. And that is 12y. Then, 9 times y prime times 1. The result is 9y prime equal to 0. Then, distribute the negative here to these terms. So, just copy the first term. So, this becomes 18y plus 3y double prime plus 4y prime. Then, distribute the sign to each term. So, negative times 2y double prime is negative 2y double prime. Negative times 12y is negative 12y. Negative times 9y prime is negative 9y prime equal to 0. Then, add like terms. So, 3y double prime minus 2y double prime is y double prime. 4y prime minus 9y prime is negative 5y prime. Then 18y minus 12y is positive 6y. Do we still have the arbitrary constants? No more, right? And our result is already in the differential equation. So this is our solution. Another example. Y equals x plus c sub 1 e to the x plus c sub 2 e to the negative x. What are our arbitrary constants? We have c sub 1 and c sub 2. So, how many arbitrary constants? 2. So, how many times do we need to derive the equation? Twice. Correct. So, first, let's write down the equation. So, y equals x plus c sub 1 e to the x plus c sub 2 e to the negative x. So, first step is to derive the equation depending how many arbitrary constants. Since there are 2 arbitrary constants, we will derive the equation twice. So, what is our first derivative? The first derivative is, for y is y prime. For x, that is 1. How about c sub 1 e to the x? Same, c sub 1 e to the x. How about c sub 2 e to the negative x? The derivative is negative c2 e to the negative x. We will derive again since there are 2 arbitrary constants. So, derivative of y prime is y double prime. Derivative of 1 is 0. Derivative of c sub 1 e to the x is c sub 1 e to the x. Then, derivative of negative c sub 2 e to the negative x is now positive c sub 2 e to the negative x. We will stop here because there are only 2 arbitrary constants. Then, as you can see, there are common factors, right? C sub 1 e to the x and c sub 2 e to the negative x. So, x and 1 should be transposed to the left side. So, this becomes y minus x equals c sub 1 e to the x plus c sub 2 e to the negative x. Then, y prime minus 1 equals c sub 1 e to the x minus c sub 2 e to the negative x. Then, the last one, y double prime equals c sub 1 e to the x plus c sub 2 e to the negative x. Then, we will use the diagonal method. In the first column, we will put all the terms on the left side. So, just put y minus x, y prime minus 1, then y double prime for the first column. For the second column, we write all the coefficients of the common factor. Our first common factor is c sub 1 e to the x. Our second common factor is c sub 2 e to the negative x. So, for the first equation, the coefficient for the first equation for c sub 1 e to the x is 1. For equation 2, coefficient is 1 also. For third equation, the coefficient is 1. Next, the second common factor. The coefficient for the first equation is 1. Second equation is negative 1. And the third equation, the coefficient is 1. Then we copy the first 2 columns. We copy y minus x, y prime minus 1, then y double prime, and 1, 1, 1. Then we will use the top to bottom minus bottom to top equal to 0. Multiply from top to bottom minus multiply from bottom to top equal to 0. So, let's start with the from top to bottom. So, from top to bottom, we multiply y minus x times 1 times 1. So, the answer is y minus x. Then, multiply again from top to bottom, 1 times negative 1 times y double prime. The answer is negative y double prime. Then, multiply diagonally 1 times y prime minus 1 times 1. The result is y prime minus 1. So, this is from top to bottom. Then, minus bottom to top. So, bottom to top, multiply y double prime times 1 times 1. So, the result is y double prime. Next, multiply diagonally from bottom to top. And from bottom to top. So, 1 times negative 1 times y minus x. The result is negative y minus x, right? Then, multiply again from bottom to top diagonally. 1 times y prime minus 1 times 1. So, the result is y prime minus 1 equal to 0. Then we distribute. So for the first terms, just copy y minus x minus y double prime plus y prime minus 1. Then distribute negative. Negative times y double prime is negative y double prime. Negative times negative, this becomes positive. So positive y minus x. Then negative times positive y prime, negative y prime. Negative times negative 1 is positive 1 equal to 0. Then add like terms. Y double prime. You write first the highest derivative. So y double prime. Negative y double prime times negative y double prime is negative 2y double prime. Right? Next is y prime. Y prime minus y prime. Is that correct? Y prime minus y prime is 0. So this one is cancelled out. Then we have the constants. So y minus x. So y minus x plus y minus x. So y plus y to y. Negative x minus x is negative 2x. Then negative 1 plus 1 is 0. Then make sure that the first term is positive. So we will divide both sides by negative 2. So whatever, then make sure that our highest derivative, the coefficient must be 1. So divide both sides by negative 2, negative 2, and negative 2. Negative 2. So the result here is y double prime. Here is negative y, and here is positive x. Then 0 divided negative 2 is 0. So this is our answer. Next, elimination of arbitrary constants by substitution. It is also used when two or more arbitrary constants are present. First step is to take the derivative of the equation depending on the number of arbitrary constants. Then next, find an equation that you can replace to an equation and makes the equation simpler. Okay, example number 1. Y equals c sub 1 e to the x plus c sub 2 x e to the x. So there are how many arbitrary constants? We have 2, meaning we will derive the equation twice. So first step is to derive the equation. Then find an equation that you can replace to an equation and makes the equation simpler. So write first the equation. Y equals c sub 1 e to the x plus c sub 2 x e to the x. First derivative, y prime equals derivative of c sub 1 e to the x is c sub 1 e to the x plus the derivative of c sub 2x e to the x. Since there are two functions, we have c sub 2x and e to the x. So we will use the derivative rule. What will be our u? Our u is c sub 2x. Then our v is e to the x. Then the derivative of u is c sub 2. And the derivative of v is e to the x. Then using the product rule of u times v, we use the formula uv prime plus vu prime. So write down first u, and that is c sub 2x, then multiplied to v prime. So v prime is e to the x plus v. V is e to the x, then multiply to u prime. U prime is c sub 2. Rearrange, we get c sub 1 e to the x plus c sub 2x e to the x plus c sub 2 e to the x. Then find an equation that you can replace. So c sub 1 e to the x and c sub 2x e to the x is same Same in the original equation, right? We have c sub 2 e to the x plus c sub 2 x e to the x. And c sub 1 e to the x plus c sub 2 x e to the x is equivalent to y. So we can replace c sub 1 e to the x plus c sub 2 x e to the x equal to y. That is the by substitution. So find an equation that is repeating. Since c sub 1 e to the x plus c sub 2 x e to the x is repeating, then you replace that one to other term. So since c sub 1 e to the x plus c sub 2 x e to the x is equal to y, so this one becomes y. Then copy c sub 2 e to the x. Then we continue. Since there are two arbitrary constants, we derive again. So derivative of y prime is y double prime, and derivative of y is y prime, and derivative of c sub 2 e to the x is c sub 2 e to the x. So what is repeating again? C sub 2 is repeating. So we need to isolate c sub 2 e to the x to the right side. So y prime, y should be transposed to the left side. So it becomes y prime minus y equals c sub 2 e to the x. So substitute c sub 2 e to the x to the last derivative. So y double prime equals y prime. So c sub 2 now is equal to y prime minus y, right? Find an equation that is repeating. Then you replace. Next, rearrange or add like terms. So y double prime equals y prime plus y prime is 2y prime minus y. Then you put all the terms in one side. Since the highest derivative is positive on the left side, so all derivatives must be, or all terms must be on the left side. So transpose y double prime minus 2y prime plus y equal to 0. So this is now our answer. Okay? Another example. Eliminate the arbitrary constant of y equals a e to the 2x plus bx e to the 2x. So there are two arbitrary constants. We have a and b. So two arbitrary constants. So first step is to derive the equation. How many times? 2, since there are two arbitrary constants. So write down first the equation. Y equals a e to the 2x plus b x e to the 2x. Then derive. Derivative of y is y prime. Derivative of a e to the 2x is 2a e to the 2x. Then the derivative of bx e to the 2x, since there are two functions, so we will use the product rule. Then our u is bx, our v is e to the 2x. What is the derivative of bx? B only. For v, the derivative is 2 e to the 2x. Then we will use the product rule. The derivative using the product rule, we have u v prime plus v u prime. So we copy u first. Our u is bx. Then multiply to the v prime. V prime is 2 e to the 2x. Plus v, copy v e to the 2x. Then derivative of u is b. Rearrange. So 2a e to the 2x plus 2bx e to the 2x plus b e to the 2x. Get the common. Common for these two terms is 2, right? So put the common term outside. So this becomes a e to the 2x, then bx e to the 2x plus b e to the 2x. So what is our repeating terms? Our repeating terms is a e to the 2x plus bx e to the 2x. So same here. And this will become y. So y prime equals 2. So this one will become y plus b e to the 2x. Do we need to continue deriving the equation? Yes, since there are two arbitrary constants. So derive again. Derivative of y prime is y double prime. Derivative of 2y is 2y prime. And the derivative of b e to the 2x is 2b e to the 2x. Then, what is repeating? We have the b e to the 2x, right? So, let's arrange this equation. So, transpose 2y to the left side. So, y prime minus 2y equals b e to the 2x. Then, substitute that to this equation. So, y double prime equals 2y prime plus 2. Then, b e to the 2x is equal to y prime minus 2y. Then, distribute y double prime, 2y prime plus 2 times y prime is 2y prime. 2 times negative 2y is negative 4y. Add like terms, so 2y prime plus 2y prime is equal to 4y prime minus 4y. Our highest derivative is y double prime and it is positive on the left side. So all terms must be on the left side. So transpose y double prime minus 4y prime plus 4y equal to 0. Then, this is our final answer. No more arbitrary constants, and the result is already in differential equation. So, those are the methods for the elimination of arbitrary constants. More examples are on your PDF. So how to check if your answer in the elimination of arbitrary constants is correct? This time we will use our calculator. So example, we have y equals c sub 1 e to the 2x plus c sub 2 e to the 3x. We already solved this one. Then our answer is, let's check what is our answer. So this one is our problem, y equals c sub 1 e to the 2x plus c sub 2 e to the 3x. And our answer is y double prime minus 5y prime plus 6y. Okay, let's check if that answer is correct. So the answer is y double prime minus 5y prime plus 6y equal to 0. So let's check if this is the correct answer. So first step is to let x equal to 0. Then c sub 1 equals 0.1. Let x equal to 0. Then c1 as 0.1 and c2 0.2. But c1 and c sub 2 are arbitrary constants, so it can be any value. So it is much easier if we use 1 for c1 and 1 also for c2, right? Because it is any number. Next step is to derive the dE depending on the number of, derive the equation. This one is not dE, but derive the equation, the original equation, depending on the number of arbitrary constants. So we derive. So derivative of y is y prime. Derivative of c1 e to the 2x is 2c1 e to the 2x plus c sub 2 e to the 3x. The derivative is 3c sub 2 e to the 3x. Derive again, y double prime plus 4c sub 1 e to the 2x plus 9c sub 2 e to the 3x. Then you input the values Okay? So, what is y prime when x is equal to 0? And c sub 1 is equal to 1 and c sub 2 is equal to 1 also. So, x is 0. So, 2 times 0 is 0. E to the 0 is 1, right? So, e to the 2x becomes 1. Then 1 times c1, c1 is 1, so 1 only. So, y prime is equal to 2 plus e to the 3x, and x is 0. 0 times 3, 0. E to the 0 is 1. 1 times c2, c2 is 1. So, 1 times 1 is 1. 1 times 3 is 3. So, y prime is equal to 5. Substitute again the values. So, e to the 2x, this becomes 0. 2x becomes 0 since x is equal to 0. Then, e to the 0 is 1. 1 times c1, c1 is 1. So, 1 times 1 is 1. So, 1 times 4 is 4. So, y double prime is 4 plus e to the 3x, x is 0. 0 times 3, 0. E to the 0, 1. 1 times c2, c2 is 1. So, 1 times 1 is 1. 1 times 9 is 9. So, answer is 13. Then, you replace y prime. So, y double prime is 13, right? Minus 5. Then, how about y prime? The result is, the value is 5. Plus 6, and what is y? So, we did not get the y yet. So, e to the 2x, e to the x is 0. 0 times 2 is 0. E to the 0 is 1. 1 times c1, c1 is 1. 1 times 1 is 1. Plus, e to the 3x is 1. 1 times c2, c2 is 1. So, 1 also. So, 1 plus 1 is 2. So, our y is 2. So, 6 times 2. The result here must be equal to 0. When the result is equal to 0, then your answer is correct. So, 13 minus 25 plus 12. 13 plus 12 is 25, right? Minus 25 equal to 0. So, we got the correct answer. So, this one is correct. That is how you will determine if your answer for the elimination is correct. Okay?